Hello and welcome to Chapter 2, Section 2. Today we're going to talk about reflections. First, we're going to start by looking at the Explore portion of this section. How to flip something over a line. The easiest way to do it is to fold your paper along the line and trace. And you can see how if there is a point on the line and you flip it, that point remains in the same spot on the line. Everything else remains the same distance from the line and it crosses over it exactly. Our vocabulary here, we're looking at the word perpendicular. Those are lines that intersect at an exact right angle. Exactly 90 degrees makes perpendicular. A perpendicular bisector are lines that intersect at a right angle and cut the line exactly in half. And a reflection maps a point P to its image P prime. If P is not on the line, then line L is the perpendicular bisector of line P, P prime. Let me explain what that means. If I have line L and I have a shape that looks like that, A, B, C, and I were to flip it over this line, and I am doing a very poor job. Oops, prime goes up at the top, C prime. If P is not on the line, so let's say that's P, then line L is the perpendicular bisector of this line. If we connect point B to point B prime, this not only is a perpendicular line with line L, it's also a bisector, which means this is the same length as this side. If P is on the line, then it's the same point. P equals P1. To start this, we're going to get some graph paper and we're going to draw an exactly diagonal line. So here we have a line that we've drawn exactly diagonally, connecting all of the points, and we've drawn a random shape ABC. And so if we're looking at example 1A, in step 1, it asks us to draw a segment with an endpoint at vertex A so that the segment is perpendicular to line L and is bisected by line L, and label the other endpoint of the segment A prime. So if we're going perpendicular to this exactly diagonal line, it's going to be exactly diagonal the other way, which is why we started with this, because it's a little easier to deal with. We're going to draw a line that is exactly diagonal this direction because we know that will make a perpendicular line. Now, if we take point A towards line L 1, 2, 3 places, we're going to go 3 places beyond line L, 1, 2, 3, and that's where A prime is going to be. B goes exactly diagonal, perpendicular, 1 spot. So we're going to go 1 spot, and we're going to say B prime. And we're going to go 1, 2 spots, and 1, 2 spots, and that's going to give us C prime. And when we connect these lines, this is an exact mirror image of its pre-image. And we have created 3 lines, 3 pairs of lines, 1, 2, 3, 1, 2, 3, that are perpendicular bisectors of each other. So this is how we set up example B. Now example B does not have an exactly diagonal line. It goes up 1 and over 2 for its line. So when you go towards it, you're going to So the vector here is over 2 up 1. So the perpendicular bisector is going to have a vector that's exactly the opposite of it. So this is going to go over 1 and down 2. Over 1 and down 2. And that's going to create this line, which is exactly perpendicular to line L. And it did that twice. So we're going to do it again twice. Over 1, down 2. Over 1, down 2. And we're going to draw this line, and this is going to be A prime. Do that for B and C and draw your image. And when we come back, we've realized that because C is on the line, C and C prime are the same point, so we keep that there, but it is a mirror image, if I could draw a straight line, of the pre-image. So I'd like to ask you to pause here, try reflect numbers 3 and 4, and your turn numbers 5 and 6 to do this on your own. Come back when you're done. In reflection part 3, you want to double check and make sure that these are the same length. And in part 4, you want to make sure that this is an exact corner. So you're looking for the opposite vectors. Your turn number 5 looks something like this, and number 6 looks something like this. And it gets a little confusing because the shape crosses the reflection line. You're going to cross that as well, and this point are going to remain the same. But you're making sure that your vectors are exactly the opposite. So this, because this line, the vector of the reflection line, -1, 2, your perpendicular line's vector is going to be 2, 1. Over 2, up 1. This vector is 1, 3. So you're going over 1 and up 3 here. So opposite is going to be over 3 and down 1. Now, something I'd like you to realize, that not only are you switching the numbers, but you're making one of them negative. And the question is, which one do you make negative? And the answer is either one. Because if you start here and you're going this way, you're going to go over 3 and down 1, which is what we did. But if you go this way, you're going backwards 3 and up 1. So you're switching the numbers and one of them is negative. However, you need to pick the one that actually goes toward line L, your reflecting line. Because this is true as well. This line continues in that direction, and it is -2, -1. It goes backwards 2 and down 1. So you need to take it into the direction of the reflected line. When we're drawing reflections on a coordinate plane, like it talks about in Explain 2, Example 2, if we're just going across the x or the y axis, only the y or the x changes. These reflections are the easiest to do because we're going straight across an exactly horizontal or an exactly vertical line. You're only changing the distance from this line. And because this line is exactly vertical, you're just changing the horizontal. So this is A, B, C, and this is A prime, B prime, C prime, and all of the x coordinates change, but the y coordinates stay the same because you're going over in different directions and you're going up the same distance for both C's, same distance for both B's, same distance for both A's. So it gets a little easier. When you're graphing across the line y equals x, so you have an exactly diagonal line, if A equals xy, then A prime equals yx. Shortcut. So if you've got any kind of shape up here, whatever this point is, if this is point 1, 2, 3, 1, 2, 3, 4, 5, let's say it's right there, and this is 3, 13, then when you reflect it across a diagonal line, it's going to be 13, 3. 13, 3. And connecting those two will give you a perpendicular line. So if you look at example 2b, it gives you a number of coordinates and it asks you to find the coordinates of the vertices of the image, knowing that all of your x's are y's and all of your y's are x's, comma, x. And you can do that on your own. What I'm going to ask you to do is do your turn numbers 9 and 10 to get some practice with this. Pause here for a moment and come back when you're done. With number 9, we took quadrilateral STUV and we flipped it. We reflected it over the x-axis to be STUV prime. And all of the x's are the same, but all of the y's have changed. In number 10, our line L is y equals negative x. So we've taken all of our ABCs and flipped them over this way to A prime, B prime, C prime, and your end result should look like this. The third question that they're asking you in this section is if you had the two shapes, but you needed to find the reflection line. You know that the line is going to be the midpoint of the lines going from point to point prime. So your first job is going to be to connect all of the point A's to the point A primes and so on. And then you're going to need to find the middle of those lines. And last year in algebra, you learned that the midpoint formula was the average of the x's, x plus x prime over 2, and the average of the y's, y plus y prime over 2. And that's your midpoint. So there's a lot of math in this. And if you find the midpoints of all of the points and prime points and you connect those midpoints, then you get to draw yourself a line. So your book takes you through example 3A, where you're given ABC and ABC prime. And it asks you to draw a line from A to A prime, B to B prime, C to C prime, and find the midpoint of these lines. So the midpoint of A prime is this point and this point averaged together, and that gets you 1, 1. B to B1, C to C prime, and so you end up with these 3 points and you draw a line through them, and that gives you your midpoint. And line L is that line of reflection. So I'm asking you to look at example B and try the math and see if you can find those midpoints and draw that line on a graph of your own. Pause here and come back when you're done.